Lawless. He was also one of the speakers at Works of Entanglement 2017 in Brussels. Exactly.
It was much cooler.
It was much cooler. Yes. So now the microphone is not. No, it's very sensitive. No. So okay, whenever the microphone is ready, you will get it. But in the meantime, you can start.
Quantum light, a lot of people ask about what that means, and in my view, here's the driving motivation for this approach. When you measure human beings, like if a wife asks her husband where he was today, that's going to have an impact on the husband before he gives an answer. And so that was the first motivation. We know that measuring human beings is very inaccurate, and the results are subjective. And the second reason is because it's very difficult to pull things apart. When there's an argument or a fight between a husband and a wife, or between two businesses, and I'll talk about that as well, it's very hard to understand who was right and who was wrong. Humans don't usually just say, I'm sorry, I was wrong, you were right. They have to go through a very difficult process of unpacking the problem. But that's the motivation for this, and let me just wait a minute, and I'll go ahead and get started. This is where my team is at this point. We've published 4 books. The 4th book, we just published the 4th book in February, just recently. We have a contract for the 5th book, and the books that I'm the lead editor on, the books that we're publishing are based on context that on a conference that we have each year at Stanford. And we've got the next conference is coming up in just 2 weeks. But what I want to talk to you about in this talk is a special issue of Artificial Intelligence magazine on computational context. Last year, a year ago, an Uber self-driving car hit a pedestrian and killed the pedestrian. And there was a National Transportation Safety Board evaluation, an accident investigation. And based on that investigation, the Uber car saw the pedestrian 6 seconds early, hit the brakes 1.3 seconds early, which was appropriate, but the brakes had been disconnected by the engineers to help the Uber car ride better. Thank you. What about the human? There was a human operator. The human operator picked up the pedestrian 1 second early and hit the brakes 1 second after hitting the pedestrian. So I think there are a couple of really bottom lines to pick up here. The Uber machine worked as it was designed to work, but it was disabled. The human was late. The other thing to pick up is that the Uber car was a poor team player. The Uber car could have alerted the driver 6 seconds or 5 seconds before the driver actually knew that there was an object on the road. So but that's a problem that we can fix, building context. Now this is a pretty straightforward, simple problem. And there are much more complicated problems that are coming up. And
I have a question.
Yes, I'm sorry.
Why did
We need the microphone.
my immediate reaction to that would be, why didn't the cars initiate the braking before that?
It did. It did.
No, but
1.3 seconds was
it took it almost 4 seconds.
Yeah, but that was the design. You can argue with the design, but that was the design point to hit the brakes.
At the design point, so
yeah.
you calculated the impact factor.
Right. And that's when it hit. When he hit the brakes, that was appropriate. The fact that the brakes were disconnected, that was the engineers. And they'll lose a lot of money as a result. Let's see. So here's where we are today, and here's why the problem is important. Decreased reaction times are becoming a very important issue. Before the Uber car wreck, I worried about military swarms. What are we going to do when there are military swarms engaging in combat? And that, I'm late to the question because a year ago, swarms of crude aircraft weapons, as weapons, were launched against a Russian base and killed Russian soldiers and destroyed a lot of aircraft. And however, the Russians deny that any soldiers were killed, and the Americans deny that there was any involvement by them. Until this year, mutually assured destruction gave you 30 minutes before you had to worry about an all-out nuclear war, which is a pretty important thing to worry about. However, hypersonic missiles were introduced into the lexicon last year, and now the Russians claim that they have hypersonics, and the Americans just a couple weeks ago claimed that they have hypersonics as well. The problem with hypersonics is that it's going to decrease the reaction time even further than 30 minutes. In fact, you could launch a nuclear weapon off the coast of the United States, or off the coast of China, or off the coast of Russia. So there's virtually no reaction time whatsoever. What that means is that we'll have to depend on machines to help make decisions. The good news is that the Uber car, the machine, worked as it was designed. Maybe it could have reacted faster, but it worked correctly, and the human did not. So there's some solace in that. But the big question is, are we ready to turn authority over to machines to make decisions? Now, we could have done this a couple of decades ago. We might have been able to prevent 9/11. We might have been able to prevent the German wings aircraft suicide. Remember the young co-pilot committed suicide a couple of years ago and killed 150 passengers. In those cases, we have the technology now to let the machine take over from the human. See, here's one of the things about machine learning that's really important. When you have trained the machine what to do as part of a team, the machine knows what you're supposed to do as part of the team. And so the machine will know first when you're messing up. And so the machine in the German wings case, and we've had a couple of major accidents with death ensuing from trains crashing. The machines could take over when they know that the human is messing up and save the aircraft, save the train. And in fact, for combat fighter pilots in the United States, we already have that technology deployed. So if a pilot goes into a high G maneuver and passes out, the plane takes over, puts itself into a safe position, and waits until the pilot recovers, and then the pilot can take back over. So these are important decisions that we have to discuss and argue about and make decisions on. Here's a short précis of my research. I'm going to be talking about interdependence, which is what I think qualifies social science to be quantum-like. Nobody likes interdependence because it's very difficult to study. And I've arbitrarily broken it down into 3 parts: biasability, a measurement problem, and non-factorability. And we'll talk about those 3. And then I'll talk about my first 2 findings, which deals with redundancy, and my 3rd finding, which deals with intelligence in teams. A lot of people don't really understand bistability. This is social dualism. But here's a really simple example published by Carroll a couple of years ago. If you have prey, deer, in a forest, and they don't believe that there are any predators about, they will overgraze, and they will destroy the forest. But if there are predators about, if there's a lion about, and they think that they're there, that's all it takes for the prey to eat and help the forest grow. So the prey takes a bite of grass and scans, takes another bite of grass and scans. So it leads to a healthier forest. There's a really good example. Here's another good example, which is an operating room with a bunch of surgeons and nurses. Each one is doing his or her own job. And that's an example of orthogonal roles, so that the different roles that are being played, they're picking up different information. And that information statistically is independent. And that's a really important point. Here's a bistable illusion, which is a young woman looking over to her right shoulder and an old woman looking down. It's an orthogonal interpretation, which is a bistable illusion. One of the things that we know about this illusion in particular is that if you focus on one interpretation, you cannot see any part of the other interpretation. That's a really important thing. We also know that countries like the United States, which have a lot of bistability, are earning a lot more money off of their patents than the Chinese. And the Chinese have just about as many patents as the United States. Here's the problem. In traditional social science, action and observation are considered one-to-one. So what I see from a social scientist perspective is exactly what's taking place in the world. So we have, as a result of this, we had the cognitive revolution. But there's no support for that whatsoever. Why social, and I'll talk about why that's a problem. Why is social science so hard to replicate? Why don't self-reported observations of behavior, why isn't that equal to the real behavior that's taking place? Here's a really good example of a measurement problem right here. These women were taking pills to prevent getting HIV from their male partners. And at the end of the study, they were asked to report their levels of compliance. And the women reported that they were compliant 95% of the time. And they turned vials back to show that they had taken almost all of the medicine. And that indicated that the study failed. But fortunately, they collected blood samples at the same time, and it turned out that the women compliance was only at 25%, 26%. So this is the disease specialist. She said we were profoundly disturbed by that result. So the problem is that social states are interdependent. And yet, interdependence in the laboratory in particular, but in my area is in theory, it's bewildering. And so as a result of this claim by one of our most distinguished social scientists, the study of interdependence pretty much stopped until 2015. And in 2015, the National Academy of Sciences said, wait a minute, we're finding interdependence all over the place. And one of the guys was Cummings, and Cummings concluded in public that the very best teams are highly interdependent. So that another word for interdependence is reactive. So if I know you're on a line with me making tools and you need this, and I know I anticipate when you're going to need something and I can get it to you, that's an example of interdependence and coordination and reactivity. What can I say at this time about social decisions? That there are broadly two types, and I know this is a bad generalization to make, but there are broadly two types. There's minority control, like an authoritarian Consensus seeking is actually a way to control the group. And there's also majority rules. I like majority rules a lot because I've seen it in action, and they actually, we'll talk about the evidence. You can actually model a harmonic oscillator, use a harmonic oscillator to model majority rule effects, and it leads to, in my opinion, more social evolution. If you've got minority control, here's a line, here's a test line. We've known this for a long time. You can get people to agree that any one of these other lines is the test line. So oppression really works. But in a really open system with checks and balances, the best legal decisions result from an informed assessment of competing interests. I don't want to talk about this too much except to say that I'm going to look at intelligence overcoming barriers, and I think the future of my research is going to be in entropy gradients. I think that's one of the ways to overcome some of the shortcomings with subjectivity in the social model. So here's an example of the measurement problem. We all like to believe that our conclusion about what social reality is correct. But that leads to a lot of accidents and mistakes. This is an A. I don't know if you can see it in this one. Let me go back. This is a letter A in this block, and here's a letter B in this block. You ask the average human, and they will say, well, the A is much darker than the B, but that's wrong. They're of equal darkness, and only a photometer can tell. Here's what happens when you shut down biostability and you only have one-sidedness. Here's a picture of Korea, North Korea at night. Here's South Korea. Here's China. And here's an example of the weapon that part of a swarm that broke into the impregnable Russian base in Syria because they didn't feel like they had to worry about that. And here's where I got, here's my one claim to fame. I worked for the Department of Energy, and it had made the one-sided decision before 1983. It made the decision that cardboard boxes were safe to dispose of solid radioactive waste, and most of the 95% of the solid radioactive waste when I was there was disposed this way in cardboard boxes, and I blew the whistle on the Department of Energy. And so I don't think it makes me famous, I think it makes me infamous. After my PhD, the Department of Energy invited me to work with them, and we actually closed that barrel ground. We closed this barrel ground in 2000, completely closed, and one of the things that I've been able to observe is that at this time, the federal agency had complete control of the environment. They could make any decision it wanted to, and it did a lot of damage. At the Savannah River site, the Hanford site, maybe $200 million worth of damage. But today, at the Savannah River site, there's all kind of competition. The National Academy of Sciences, the state of South Carolina, the citizens, everybody's calling all over the site. And the thing that's really interesting to me is that the decisions that the Department of Energy is making are pretty good. So what do humans do about biostability? How do they exploit it? And how do they avoid the incompleteness that leads to interpretation and prediction errors? Here is a new book that just came out in 2015 by Tetlock and Gardner, one of our great social scientists. And his conclusion is that I can teach you how to predict the future. It's called super forecasting. His team of hand-picked super forecasters, their first prediction was that Brexit would not happen. And their second prediction was that Trump would not get elected. And they failed in both of those predictions. Here's the problem. You can see interdependence right here. And I'll have to point it out too. This is a set of poles. It's all the poles that were available. They're averaged out. And you can see that the real clear average of the poles is that the red guy wins and the blue guy loses. But that's not what happened. What happened was the blue guy actually won the election and the red guy lost. Because there's a lot of interdependence in here, which is making it work like a limit cycle, and so you can't get clear data. If opposed teams had a quasi-national equilibrium drive evolution, which I think it does, can we model human machine teams with Shannon information theory? The answer to that is clearly yes and no. Shannon information theory, the problem with it is that there are no social effects. Conant, using Shannon information theory, concluded that teams work best at a minimal interdependence or minimal communication, but zero Shannon information for teams. The best that you can do there is to control the swarms. And as I've already pointed out, contradicting Shannon information theory, the most productive science teams are highly interdependent. The other thing is that I believe maximizing interdependence, according to the evidence, maximizes exploration and productivity. Well, how do you go about modeling something? How do you model role orthogonality when measuring a social context affects the social context? Well, I think you can do it by recognizing what's taking place, that action, the motor skills that we have, and the observations, those are two independent systems, and they're complementary, and that leads to something like an uncertainty principle. And the third characteristic of interdependence is non-factorability. It's very difficult in a fight to know who was right and who was wrong. Here's an example of what happens if the fight continues. That's the civil war in Syria, and you can see it slowly disappearing from 2012 to 2014. And when corporations like CBS and Viacom fight, they lose a lot of profit. And these two corporations are owned by the same company. So it's an internal fight, like a divorce. And I like this example a lot. This comes from Gazzaniga. Everyone's got an integrated brain, and you can't really tell when you're seeing things with the left eye or the right eye. But one of the things that Gazzaniga did as a graduate student is that he studied split brain patients, and he found out that the two halves of the brain do not communicate at all once they're split. And so here you have a team that's been split apart that sees reality completely differently. And that's a really disturbing but important finding. Here's what I think about non-factorable information. It indicates to me that perfect teams may be subadditive. So if you shock a very poor team, like if you've got a couple who are not divorced, they're still married, but you put a pretty woman or a good-looking man, insert that into the equation, that's a perturbance that will really generate tremendous amounts of information. So the thing about a bad team is that they generate too much information. And here's something that Thomas and I were talking about today. This comes from, this one right here comes from Cummings. Interdisciplinary teams produce the worst science. The problem there is one of measurement. At least Thomas and I think so, that we don't know exactly what's being measured, but it's supposedly the team productivity. So the thing about interdisciplinary teams is you've got to be careful, make sure you're really onto it. Make sure the team is working as a team. On the other hand, disturbing the best teams generates too little information, and that's an example of sub-additivity. In the limit, a perfect team can go to information darkness. An example of darkness is that great golfers need coaches. They don't know what they're doing wrong. And the other thing about perfect teamwork is that it leads to maximum entropy reduction. If interdependence is bewildering, what can we predict? This is a really tough one. I mean, it took me a while to get to it. So I think that what you can predict is you can look at the effects of interdependence and predict what will happen over the long term. And so that's what I did. I ran into this conclusion first from social network analysts. As redundancy increases, the network becomes more efficient. And then I ran into this from the National Academy of Sciences. They said that the size of teams is an open problem, but many hands make light work. And so I took that one on as a problem. Oops. And my prediction was just the opposite, that maximum interdependence minimizes redundancy. Another way to say that is that the more redundant personnel you have on a team, the worse the team will perform. And that's what I found. The first one was published in the Journal of Mad Psychology, the second in the Frontiers of Physics. The first test contradicting social network theory and the academy, redundancy impedes interdependence. Second test, interdependence is related to freedom and inversely to corruption. So that the more corruption you have in an organization, the less likely there's teamwork going on. That's pretty straightforward. So the third test, which I've got submitted and under review, do perfect multitasking teams use intelligence, and there's virtually no support from social science. I found support using the United Nations data in 19 MENA countries. MENA is Middle East and North African countries, plus Israel. And what I found was this finding right here, which I like a lot. The reason why I like it is because it contradicts a finding I got in 2001. The finding in 2019 indicates that the amount of schooling in a nation is proportional, strongly correlated to the number of total patents produced by the country. The finding in 2001 was with top fighter aircraft. Schooling there was completely unrelated to performance in combat. But training was very strongly related. So here's a model of intelligence which I'm working on now. How do you model it? It's very hard to do, but I think you can use Markowitz's portfolio theory from the stock market. So the more neutral the correlation among the stocks, the better your portfolio. And I think you can use superordinates, which I got from Ibn Khaldun and the 1300s, which means cohesiveness, so that different elements of the team put together that way. And I like this. One of the things that comes right out of this theory is that you get two states. I know there might be more than that, but there are at least two. There's a ground state where you've got sub-additivity taking place, and an excited state. This is like a couple getting divorced. When they're getting divorced, they're tearing the structure apart. So they have no energy left over to raise kids or to solve the problems of life. On the other hand, down here at ground state, if you've got intelligence in the team, and you're at a very low state, and you're working together very well, you're able to devote most of your energy to solving the problems of life. That gets me to the conclusions. Skynet is coming. Can shared context defeat it? I think it can, but I'm also dubious. The first conclusion I've got is that competition, only with competition can we know what people are actually like. Self-reports, static reports cannot capture individual skills, team fitness, performance, nor interdependence. Competition identifies perfect and dysfunctional teams. That's the only way I know that you can actually find out what people are like. All these MBTI, personality quizzes, they don't really tell us much at all. Second, reducing interdependence weakens teams, so that the more redundancy you have in a team, the more corruption you have in a team, the weaker it becomes the team. Third, sub-additivity of interdependence looks like a real winner. It has a problem though. The best teams evolve, they're resilient to perturbations. The perfect teams are irreproducible, and it's very, very difficult to get any information out of them at all. You can't even get them to reproduce themselves. And finally, for human-machine shared context, either agreement exists with adversary. Here, I don't mean your enemy. I mean a person who disagrees with you. So either agreement exists with an adversary, and you can come to what's known as a bipartisan agreement, where, okay, you say this and I say that, but let's do this and we'll move on to the next problem. So that works very well. And there are examples in the U.S. Congress of all places where they can't seem to get agreement on anything. Superordinates cohere a team and make it into a unit. And context can only be determined by neutral voters. Thank you.
Thank you, William. We have time for a couple of questions. Anybody wants to ask a question? Okay.
Yes, sir.
You concentrate on teams, but what about individual action?
Yeah, I think that's a really good question. I think here's what we can say about individuals: virtually nothing. At least that was my position 2 years ago. I'm beginning to change the position, and here's why. Neutrals apparently can enter into a superposition, I think. If you've got conservatives and liberals, I'm not going to be able to change the conservatives' mind or the liberals' mind, but I can change the minds of neutrals. No matter what the news looks like, most of the people in the United States are neutral. They're independent, so they can be swayed one way or the next. And the neutrals usually determine who wins an election. So that's gotten me to change my mind that actually individuals are extremely important, but they help us decide what the decision should be. If you mean like on individual psychology, virtually not.
Yes, but in some sense,
Microphone, please.
there are best way to educate individuals. For example, Brexit is a paradoxical thing. That is, people have wrong ideas in their mind that they regret now. So it can be seen as a lack of something, information, education, and education.
Well, I'm not a British person, and I don't read the newspapers there very much, but I do read about it. I think it's a complicated issue. I think there are a lot of people in the rural communities who felt left out. Macron wrote a letter, an op-ed last week, and I thought he was trying to make some good suggestions. He was trying to say, let's get everybody together, and maybe we need to revise the treaties somehow. I like that a lot. I think one of the problems with Europe, George Soros wrote an op-ed 2 weeks ago, and he said that Europe is fracturing right now, and that Europe needs to wake up and do something. I don't know as much as Soros knows about Europe. But he's a keen observer of Europe, and he likes Europe a lot, and I hope that Europe doesn't fracture myself, personally. Whether education is the key, I mean, there are a lot of educated people on both sides of every issue. Look at, my really best example is look at quantum mechanics and how long we've been arguing about the interpretation of quantum mechanics. It's almost 100 years. Since they've been fighting over what this means. Does that help? So I don't know if education will help. But I do hope that Macron's idea of let's get together, don't let the UK split off, let's try to find some way to to let people feel more democratically involved. I think that's the problem. Somebody else?
Next question. Thank you.
Just wanted to ask you, would you say that asabiya is at work in fundamentalist groups?
Yes, I like the word. I don't know how to pronounce it. If you ask me how to pronounce it, from Khaldun, Ibn Khaldun, in the 1300s, 14th century. I don't know how to pronounce it, but I'm very impressed by the word. And some of his ideas are quite important. One of the things that it can do, if I apologize, but if you're the husband and I'm the wife, we're going to see things completely differently. Like the split brain problem I talked about, so the two halves of the brain see reality differently if the brain has been split. If we take the husband and the wife who are having problems and we separate them and analyze them, they're going to give us information that can't be used to recreate the problem. We've known that for a long time. So the correlations between the two will be zero. So there's a famous saying in social science that, let me see if I can get this right, that if there is a correlation, it means that there's no causality. Right.
Doesn't imply.
Right. But if they go on one more step and they say that there's no correlation, that means that there's no causality. And I disagree with that. I think that if you've got orthogonal roles, you're going to get a zero correlation. And so like Markowitz and neutral portfolio, you can still have a portfolio that works for you in the stock market, even though there's zero correlation between, say, real estate and General Motors, something like that. Does that help? So cohesiveness, the husband and wife can agree that they want to work together, even though they disagree with each other's interpretation. A reality, we can raise our kids. CBS and Viacom, two different businesses, they can agree that they work together to solve the problems that they both face. Does that make sense? And that's asabiya. Okay, so the correlation there goes way up. The cohesiveness correlation goes up. The information that you have, which is orthogonal to my information, is zero. But we still work together. Does that make sense?
Yeah. Next question, Yukio.
Yes.
Road.
Thank you for your talk. And I think there's a viability I can see the question and the answer can lead to viability because, for example, the second question, the question of what is glass. Once there is a question and there is no answer. But if I answer, I indicate the same. Yes, the question disappears. So the answer and question are stable. And the simple question is, but the very deep question, or what is example, or for example, what is life, or what is mind, or what is consciousness, or something like that. I can temporal answer, and at that time, the temporal answer or temporal question coexist, and the relationship, a pair of question and answer, hang up in the middle air. So, the other case, there's no master case, and I think such kind of relation is related to creativity. For example, masterpiece, that is just Uranus, but intended by Apostel. And the purpose of the intention of the masterpiece is as a fountain, and the realized masterpiece is Uranus. And this relation is compared to the question and the answer, and they coexist. And the new concept or creativity or new concept appeared outside of this relation, and is formed into the gap of the initial and realization. So,
Well, no, I agree with you. I think that that's really important. There's an argument even today about where Einstein came up with the special theory of relativity. And the argument revolves around which piece of evidence he had. Was it the Michelson study, or was it much earlier than that? Some people begin to think it was much earlier. So that's an example of non-locality.
Thank you, Bill.
Thank you. Well, I'm afraid I have to be a little bit controversial with respect to the European Union. But first, let me just point out that just as Apostel said, you cannot not communicate. It's also true that you cannot not have correlations. And the buzzword I'm just saying is Ramsey theory. Please have a look at Ramsey theory. There's a very nice review in Scientific American about Ramsey theory. Ramsey theorem says basically that if a homogeneous set is large enough, you can have all kinds of laws or correlations. Every imaginary correlation shows up. And you may call that spurious, and Hume basically called that spurious. So this is in a long tradition of European thought. But this is just a technical remark. The more politically incorrect remark I would like to say is that we let's say the intellectuals, in particular I would say left intellectuals always act as if they would know what's best for the people, you know? And they are very surprised that sometimes the people vote differently, and then they say, well, but they were just afraid of it, you know, this kind of argument. And in particular Europe, what the European intellectuals, I believe, don't realize is that there exist several layers below these kinds of arguments. And one of the layers is that one of the major driving forces, I'm sorry, I'm writing revisionist history now, of the United States after World War II was to contain communism, and that is the Russians. You know, now they're containing the Russians, which was always an Austrian thing. You know? We were always interested, I mean, in Serbia, the entire World War I started because we tried to contain the Russians. You know? So now it's the Americans, you know? And one of the big fears of the Americans always is that German technology and Russian resources would combine, and this would then be held against the dominating force of the Anglo-American continent. Very seldom this is said, but the EU was created in the Montano Union against the Gaulle, who hated to put together with the Germans. There's another question, the German question. The French didn't like to go together with the Germans. But the Americans basically pushed, I mean, since when the Gaulle ruled, they couldn't get them too close together, but they pushed them into unity. And what happened after the decay of the Soviet Union proves, I believe, what's really going on. That they want to encompass, that they use an instrument of the American policy to contain the Russians now, which I'm not against. You know, I think the Russians pose certain threats. As I said, as an Austrian, I can understand that very well. But it is a thing, and your country had your share about this, you know, in Chile. You know, you had your share about containment of communism, or how they call it, and also the Italians had their share. You know, I think there are certain things, and one of the things that for instance, in this context, in this political context with the Brexit, is that that Britain always is a close ally of the Americans. So this was a complete miscalculation to stage a Brexit. You know, it just happened, and probably happened. It was also a miscalculation to go into Iraq, of course, but one of these miscalculations of American global foreign policy was to have them there, and now they have the problem that if Brexit happens, I still don't believe it happened, because this is the containment, then the Germans and the French will be more or less dominating the European community, and what happens after nobody really knows, in particular with respect to the Soviets, to the Russians. So there are certain, and now this is my second, so this is totally disrespected in the discussions that are going on. This is an undertone. And one thing I wanted also to mention is that recently I read Aristotle. And Aristotle said, would have characterized our systems, including the Austrian one, not as democracies. He said very clearly in several translations, including the Oxford translation, the recent Oxford translation of the Politeia, it's not oligarchies vote,